So we are beginning Unit 3, and Unit 3 is talking about function composition with derivatives. Now listen, a quick recap. F of g of x. It's very, very important that you understand compositions. Otherwise, chain rule is a little bit difficult to see. F of x is x to the 7th. G of x is 3x plus 5. So if I were to build f of g of x, that means put this function as an input value into f, where you see x, it would build this function composition. We good? Two-step process. The output from 1 gets plugged in as the input of your second function. So, sine of x is f of x. X cubed is g of x. So f of g of x means let's plug in our f of x, or sorry, our g of x function into f, where you see your input variable waiting for an input. So it'll be sine of x cubed. These parentheses are extremely important because it's showing where that input value is receiving from g of x. Okay? I'm overkilling it just a little bit so I can make chain rule easy for you, okay? X cubed is f of x. Cosine of x is g of x. So f of g of x, I'm going to put all of g of x into f. So everywhere where x was at, cosine of x was replaced. So it's like x cubed. Okay? And yes, if you wanted to write it as the correct notation, I'd want you to write that. Cool? So, cosine cubed is the same as cosine cubed. These are not the same as that, because you know that's what the interpretation for that one is. Cool? Okay. Here we go. So it's a two-step process with compositions. So when we need to find the derivative of compositions, or these composite functions, we use the chain rule. Okay? Guys, what's the rule? What's the rule for product rule? First times the derivative of the second plus the second times the derivative of the first. So this is just another rule that you're learning when you see a composite function. Okay? Here's an example of a composite function. It's a composite function because it's really made up of two functions. I could say f of x is 3x squared plus 5, and I could say g of x would be what? Nice. From the examples that we just did, x to the 7th. Because the composite function that this was creating was putting in f of x into what? Into g of x. And it looks like this. You with me? G of f of x would create this, the way that I did by this example. Any questions? Because you got to ask them early. And then the Oreo cookie will finish it off very easily. Otherwise, like we allocated a whole day for chain rule, I don't think you need a whole day. If you learn it correctly, you can learn it like that. Otherwise, it is a little bit difficult. Anyway, this is the rule. It looks a lot like like what rule right now? Power rule. It looks like power rule. But the last important step, the most important step, is that we have to multiply by the derivative of the stuff that's inside the parentheses. We have to multiply by the stuff that was inside. You with me? Now, I'm going to make this easy for you. There's only, and just go with me. It's a joke, but just go with me. There's only one correct way to eat an Oreo. Okay? Arguably. Here we go. When I twist it and I change the outer piece, what I just did is this step right here. I changed the outermost shell. You with me? And change to you now means derive. I took the derivative of the outer shell. You with me? Look, nothing has happened to the cream. If you do it right, and you know what you're doing, and you're a master at this, and I've practiced. Anyway, so the cream was untouched. That's why it was carbon copied right there, still as you. And the reason why I chose double stuffed is because I want you to look at that parentheses piece as the stuff. You're just going to copy it again. What's the second step to correctly eat an Oreo cookie? You eat the cream. So this part right here is eating that cream, or otherwise you're changing the cream. It's untouched right now. Step two, I'm going to change it by, man, sorry. I'm going to do this like, anyway. This is really good. I'm going to share it, I promise. I changed the inside. That's the second piece. That's chain rule right there. Because if you don't learn chain rule, Pascal's triangle says, yeah, you're about to do something to the 7th power and then derive, you don't have time for that. Okay? That's why we do the chains. Here we go. Let's do some examples. Actually, let me pause. Okay. So the du dx means that you are multiplying, that's huge, multiply by the derivative of the cream. All right. So right now I have this function, f of g of x, and we call this function a what kind of function? Composite. It's a two-step process function. Let's change the outer shell. So you can grab your Oreo cookie and twist it, and what you just did was what? F prime of what? G of x. All of this was what you just did with just twisting the Oreo cookie. You changed the outer piece. Notice how G of x, aka the cream, if you did it right, was still intact. Okay, don't mess G of x up. Keep it nice and intact. Yeah. Anyway, so then the second process is you're going to multiply by the derivative of the cream. G prime of x. Guys, without Oreo cookie, this looks weird. And this would be a nightmare to like try to memorize. So don't try to memorize f prime of g of x times g. No, just the derivative of the outside, carbon copy of the stuff, times the derivative of the cream. Cool? Alright, so now let's go into problems because it gets complex pretty quickly, but it's not bad if you can understand composite functions. Alright. Let's go, Drew. I have all of this stuff raised to the power of 5. What's the first step of the chain rule?
Take the
Yep, and it's going to be what? 5 times all of this to the power of 4. Because what I just did was the power rule of the most outer shell. You with me? Now I'm going to multiply. Actually, let me backtrack just a little bit. Can someone tell me why nothing happened to this right here? It's g of x, and it's the stuff. When you twist it, nothing happens to that g of x. It's just the outer shell that changed. And this outer shell used to be basically something to the power of 5, like x squared, or I'm sorry, x to the 5th, became 5x to the 4th. You with me? So the original thing I was looking at like this, and when I derived it, I saw that. And all of this stuff stayed the same. Are we good? Okay. And then the last step we need to do, anyone, is multiply by what? The derivative of that stuff. Eat the cream, right? What's the derivative of the inside stuff? 12x squared plus 3. Parentheses are very, very important. Am I done? Here's what I'll say. Are there any negative powers left right now? Then you are done. Now, if you want the bonus point, like on a test, yeah, you would simplify that out. But we wouldn't do something like that for a bonus point. That's just ridiculous. We're not going to do something like that. Anything like 4 and up, we don't do. But squared and cubed, we probably would do. Yes?
You don't care about distributing the 5 to the other, to the derivative?
Nope.
Well, I guess if you were to distribute it, you'd have to multiply it out first and then distribute it.
Yeah, so like Grant said, I would probably do this Pascal's triangle all in 4, then distribute the 5, and then do these last. But I mean, you're going to do it differently. But this would not be one that I would want you to do for a bonus point. Don't do that. Okay? All right, here we go. So those of you, be honest, if you're struggling, to me, what can help you right now is to identify what is the stuff. That's why I brought you double stuffed Oreos. What is the stuff? You with me? So, looking at this, what is the stuff that you see? X to the 4th plus 2. So now, we're going to derive the outer shell. So, I was going to bring M&Ms, but I don't know if you have peanut allergies, so that's why I didn't bring M&Ms. But M&Ms, with the peanut M&Ms, are also another good example of what to use for this. Because, like, the chocolate coating is the derivative of the outside, and when you crunch into the nut, that's the derivative of the cream. Cool? But again, I don't know who had peanut allergies. So, the derivative of the most outer shell is going to be the outer shell. Okay? So the derivative of the outer shell, John, would be what? 2/3 of the stuff to the negative 1/3, because that's power rule, right? We subtracted 1, 3 over 3. John, did we touch the stuff? No. So the stuff stayed the same. Okay? And then second step is we're going to take the derivative of the cream, we're going to eat the cream, we're going to multiply by the chain, okay? And you get 4x cubed. Do I need parentheses around 4x cubed? No. Why? Because it's one term. If it's a binomial or more, then I need parentheses, okay? Now, this is not a full answer because negative powers. So guys, with negative powers, any fractional power, especially the negatives, I want you to identify that anything to the power of negative is really a denominator piece. Some of you know that. A lot of you do. Some of you don't. So if you have a negative power, this belongs to the denominator, this belongs in the denominator, and everything else belongs in the numerator. Okay? So then I could write it out as 2 times 4x cubed, 3 x to the 4th plus 2 to the positive 1/2, because cube root, right? 1/3. And then if I were to simplify this just as much as I could, you would get that. How are we doing? Good? Okay. So now we're going to do some, yes?
Would you take square roots and cube roots in the denominator, or would you just leave this fraction?
So, in the past, I used to deduct if you had negative powers, and I used to deduct if you had square roots or any fractional exponents in the denominator. But on the AP exam, they really push those negative powers. They don't want you writing those. The way they do algebraic manipulation, especially on the multiple choice parts, they push that. But on the multiple choice parts, they still have a lot of square roots in the denominator. So that's why I backed off of the square roots and the rationalizing. Because a lot of people struggle with that too. Like, they know how to rationalize this, but when I have something to like 2/3 or 5/8 or different fraction powers, it was difficult for them. That's why I just X'd that out. So just negative powers. All right, there we go. They become more involved, guys. They're not all that easy, okay? But you have to know when and where you are multiplying by the chain. At the end of today, I'm going to give you some very, very difficult ones, and if you can get those, you learn chain rule just like that. Okay? All right. Let's look at this, and at first glance, let's say you looked at it and you looked away. What would be the rule of differentiation that you think you see first? Quotient rule. Quotient rule. Because I see a fraction. But then I'll look again and then I'll look away. And what I noticed about that fraction that's going to make me rewrite this is that what? The numerator has one term and it's a constant. So I would rewrite this to that. I brought the denominator, and here's the thing, guys. How did I know to do that? From experience and from practice, and from learning how students struggle and trying to redirect those miscommunications. This is a huge miscommunication, okay? Will this be easier if you rewrote it? Yes. Will it be a lot more work and easier chance of mistakes if you did a quotient rule? Yes. You know what I mean? So please keep in mind you're developing all these understandings. Here we go. Let's derive this. Matthew, what is the derivative of the outer shell?
You get 14
14
times the inside
times the non-touch stuff to the negative what? Third. Multiply by the chain, right? Anyone, what's the chain? 2. I just put it in parentheses. Even though it's a monomial, I still put it in parentheses. Okay? So, Lexi, what does this tell me?
It needs to go in the denominator.
It needs to go in the denominator. The entire stuff. Anyone, does 14 go in the denominator? No. No. Okay? So 14 and 2 will stay in the numerator. And everything else moves. And remember, when you move it, you must change the sign as you move it. Are we good? All right. So now let's turn up the speed. Let's pick up the speed because we're going to do trigonometric functions with powers, compositions. Here we go. First of all, I would not rewrite this by bringing up the denominator. I would not, because the top term is not a what? Constant. It's a variegated function. It means it has a variable. Variegated function. So I'm going to do quotient rule. And quotient can have the chain inside of the rule.
No, thank you.
With me? Which it's about to. Here we go. So it's low D high minus high. Here we go. We're about to do D low, and we have to see it as a chain. So just treat it like scratch work off to the side, like it's its own problem, that you're just trying to take the derivative of the denominator using the chain rule. Okay? Here we go. So if you have to do this, there's no shame in that, because I want you to get it right. Do it. Write this off to the side. And we're trying to take the derivative of that, like we did with the Oreo cookie. So it would be 1/3 of the stuff to the negative 2/3. Again, this was untouched cream filling. Then we will multiply by the derivative of the chain. And again, I still do the parentheses, whether it's one term or not. And guys, because all of this is the derivative of the bottom, this is what I do. Just to keep my pieces all organized. Now I can see the first times the derivative of the second, or sorry, low D high minus high. All of this is D low. All over low low, or the bottom squared. So the bottom squared, we know this is the bottom. And if I square it, what does the power become? 2/3, because you multiplied, not added, you multiply when a power is raised to a power. A lot of algebra 2, big time in this unit, a lot, like the most. Questions? Now, let's simplify this. The only thing we have to change right now is this negative power means that that is in the denominator of what we have. Now I'm going to rewrite this so that you can see our next step. Otherwise it is super confusing if I skip it. Okay, so yeah. Okay. So let's rewrite this. I'm going to show the work. Otherwise it would be a nightmare to see what exactly did I do to keep going. But we do have to simplify this for sure because of that negative thing. So here, there's no denominator piece. There's no negative power. So what I would like for you to write is 5x squared plus 2 to the 1/3. The bottom is still this. But right here, what I want you to do to help you see what you're about to do the next step is I want you to identify that this is a denominator and this is a denominator. This is a numerator, this is a numerator, and this is a numerator. So that our numerator is 10x squared and our denominator is 3x squared plus 2 to the 2/3. And this is all subtracted. This is where the next step with simplification is going to be a lot easier to understand if you wrote it this way, in my opinion. Okay? Now, my goal, first of all, let me ask you this. Can someone tell me what the denominator of this piece is? 1. You with me? And something, if it was stressed to you in pre-cal, you see the benefit right now what I'm about to do, the least common denominator, I'm going to multiply this entire fraction by a form of what? Of 1. Which is legal. I can multiply by a form of 1 because I didn't change what it is. I'm just changing how it looks. But it's still the same value. What is that form of 1? Yep, it's all of this. It's all of this entire denominator is that form of 1. Here we go. 3x squared plus 2 to the 2/3. 3x squared plus 2 to the 2/3. Now watch, this is important. How many terms, otherwise you're going to miss this next part, how many terms did I just put in parentheses? 2. So over here, look, right here. Right here is a binomial. And what I'm about to do is just algebra 2. That's all this is algebra 2. I'm going to take all of this and I'm going to distribute it on this fraction and then on that piece right there. Okay, here we go. So let's distribute on this piece first. And then we'll distribute on this piece. Guys, when I distribute on this piece first, what happens to the denominator? What does it become? It cancels to 1. And what's left is just minus 10x squared. When I distribute this, what does the denominator become? What is this? Like, let me do it in orange so you can see it, because I want you to see it without doing 100 problems. What would the denominator become? What would the x squared plus 2, what power would it have at the very end? 4/3, because you're adding the exponents. You with me? Because when you multiply with same basis, you add the powers. If you don't see that, you need to put in your notes right now the difference between adding and multiplying. Okay? So this would become 3x squared plus 2 to the 4/3. And this last piece is the most difficult one that people struggle with. I'm going to distribute this over here. And if you do it right, what do the x squared plus 2's become? To the first power. Not all the time, but a lot of times they will do that. It doesn't mean that you're wrong.
15 times.
Okay? So it'll be 15 x squared plus 2 to the power of 1, because what do I do with these powers? I add, because I'm multiplying by the same base. Okay? So, finishing it off, this would be one like you would simplify fully. You know what I mean? Because otherwise, you could have stopped right here and gotten full credit, because you have no negative powers. But if you keep going, this is where the bonus can come in. Okay, easy bonus, right? So you get 15x squared plus 30 minus 10x squared. So the final answer would be 5x squared plus 30 all over 3x squared plus 2 to the 4/3. Now, wait, what? Can you simplify the x squared plus 2 with anything on the top? No. Can you simplify this 3 with anything on the top? No, because if you could simplify, you should have done that earlier on, right? After you added that power to see if you could cancel it out. How many terms do I have in the numerator of this answer right now? 2. Because terms are separated with addition and subtraction. So I could look at the 5. Can I divide 5 by 3? No. I know I could do it with 30, but not with 5. So I'm not going to keep reducing. I'm not going to GCF out so I can cancel with 3. We've been doing this since limits. It's just, it looks different because of all these functions now. Okay? Questions before I keep going? Yes?
So if that 3 on the bottom was a 5, could you simplify to x squared plus 6?
Yeah, you see that? If it was a 5 right here for 3, I could divide a 5 out from both 5x squared and 30, and I would have x squared plus 6 over just that x squared plus 2 to the 4/3 power. Yes?
Is it wrong if to simplify you pull the two terms like apart and then add them
It's
both
not.
to the
You could do that. You could have 2 of them separated out like that. For bonus point reasons, I won't do that. Okay? So I want you to know that. Don't go there with that. It's just not common.
Okay.
But it's skills that we still should know. It is, but there's times that you can use it that it's better. But
Yeah,
you'll learn that
this
next
one will
semester.
actually canceled out like on the left term.
Yeah.
The denominator.
Yeah, and I know what you're saying. It's just next semester we'll do that with integrals. Okay? All right. So now let's move on. I have a couple more for you, and then I'll give you the most difficult one at the very end. If you could do that, then you're gravy. All right. You know. Okay, let's do this. Chain rule. A big part of chain is the rewrite. If you can rewrite it and make this cookie look a little bit like, I don't know, rewriting is like, to me, putting it like in a spotlight or something. I don't know. Anyway. Yeah, that's weird. Let's rewrite this and then let's derive it. To me, this is a lot more manageable to do if I see it this way. Okay? And the derivative of stuff to the 1/3 is 1/3 stuff to the negative 2/3. The stuff was untouched. But we need to multiply by what? 8x plus 7. Do I need parentheses? Yes, I do. But again, I always do it just to be sure. Okay. Lexi, what should I identify right now?
You put it in the denominator.
Yep. I put this piece is considered a denominator. What else is a denominator up here anyway? 3. So then I can quickly go to the most simplified form, possibly. 8x plus 7. Can 8x plus 7 be divided by 3? Like reduced? No. Unless we do what Grant was saying as far as splitting them up in 2 fractions, but we're not going there with that yet. And we'll get 3 4x squared plus 7x to the 2/3. Done. All right. The rewrite.
I have a weird, curious question. What if you had a negative exponent in the denominator?
We will rewrite it and bring it up. Ready? Sine of x cubed is all raised to the 4th. Are these parentheses needed in black that I just drew? No. Are the ones in red needed? Yes. I'm going to leave the ones in black just so you can see. We're about to do 2 chains right now. Okay? Sometimes the problem that I'm going to give you before you leave has 3 chains.
Thanks.
Here we go. Like the wrapper. All right. No, there's no wrapper that's 3 chains. Anyway, there's 2 chains. Here we go. Y prime is 4 of this stuff to the 3rd power. Carbon copy the untouched cream right now. Okay? Now we're going to multiply by the derivative of the cream. And you should notice the derivative of the cream has 2 levels of chains. So what I'm going to do here is a huge bracket. Here we go. The derivative of this stuff, and guys, some of you may need this, don't be shameful, write it off to the side. What is the derivative of sine of x cubed? What do we start that with? The cosine of the stuff times, gotta eat the cream.
3x.
Nice, 3x squared. So this is the derivative of the cream. You with me how I showed it off to the left like a new problem? And then I'm just going to bring that in. So that, guys, how many terms do you see? No. One. This is all one term because it's all glued together with what? Multiplication.
I don't appreciate that.
I know. So we have, catch them. So we have 12. I want the numbers first. And then I want all the x squareds, x cubes, and all the functions next. And leave the trigonometric functions. I want this consistent when I grade. That way it's easier and faster for me to grade. Then I want your trigonometric functions in alphabetical order after that. Okay, here we go. So 12x squared cosine of x cubed, and then sine cubed of x cubed. So what I'm teaching you right now with all this changing and manipulating and simplifying is learning algebraic manipulation for multiple choice questions so you can be fast. Alright. And if you need to go back on the video, please do, because I want to finish these last problems, okay? Here we go. Tangent cubed of 5x. The rewrite would look like this. It's all about the rewrite, guys. It's going to make life for you so much easier if you rewrite it. Y prime is 3 times the stuff squared, power rule. Remember, the cream wasn't touched. Stayed the same. Now, here we go. I'm going to multiply by the derivative of the cream. I'm about to eat the cream. Now, if you need to show this scratch work off to the side, please do so, and you'll get better where you don't have to do this anymore. What is the derivative of tangent? Secant squared of the stuff. So secant squared of the stuff, well, we got to multiply by the derivative of the chain. What is it? Times 5. Do you notice how you stop when you go to the innermost function of the composite, like f of g of h of x, f of g of h of I of x, and stuff like that? You stop basically when you go to the most inner function. How many terms do you see? 1. What's the very first number that we're going to write in our final answer? 15. What's the next term that we're going to write? In alphabetical order. Secant squared of 5x. And then tangent squared of 5x. Okay? Alright. So, and that's all one term because they're all multiplied together. Guys, look, listen. Multiplication's here, multiplication's here. Some people don't recognize, but please don't recognize that there's multiplication there. Please don't recognize that there's multiplication there. But there is here and here. Okay?
Could you put those
Trigonometric identities?
in
Yep.
parentheses to keep them sort of lumped together?
Alright? right? So D. Should I rewrite this and bring the denominator up? No. This is a lot like the other one that we did, right? The one that had 5x. So for the sake of time,
Oh,
is it exactly the same?
there's just a 1 instead of a 2.
Oh, yeah, we're not doing that. Let's do the difficult one that I wanted you to do today. Okay, here we go. So remember that one that was, I'm not going to do it for bonus. I'm not doing that one. But the one that we did for review last time, Athi was the only one that learned chain rule. And I was like, we can't do that. It was like finding the second derivative of that really difficult one. I was like, oh, yeah, we can't do that. I'm not going to do that for today. But something of that level could be a possible bonus. Okay? Now watch. We'll go... Nope. Don't start yet. What if I gave you that? What if? Let's write that out. Secant squared of tangent of 2x. Ooh, I don't like that problem. I just made that up on the fly too. I'm going to use that. Alright, so I'm proud of myself. Alright, so I will first rewrite to look like that. Now you know why I do brackets, okay? Because too many parentheses, you're like, oh my gosh, what am I looking at? What's the first derivative level going to be? Yep, so it's going to be 2 times the stuff to the 1. And the stuff was untouched. And I'm going to try to leave it more in the same color because yours is just black and white, so that you can try to identify these a little bit better without the aid of coloring right now, okay? Now, what are we about to do? The derivative of the stuff. So we're going to multiply by the derivative of the cream. Now, this is a hefty problem, so I'm going to do scratch work. What is the derivative? The most outer layer derivative. What do you see? Secant. What's the derivative of secant? Secant tangent. Secant of the stuff, tangent of the stuff. Before it used to just be x and it was easy. But now it's u. It's more stuff is in there. The coefficient is not just a positive 1. It's not just x. So here we go. Secant of the stuff, tangent of the stuff. Now, I'll help you out. I'll color coordinate this. The stuff has not changed. This is a new level stuff. So secant tangent. But now we got to multiply by the derivative of the cream. We got to go even further. So now we're on the 3rd level, if you will. What's the derivative of the blue stuff? Secant squared of 2x. Okay? Whoops. I'll come back just a little bit. Secant squared of 2x. And what are we going to multiply by at the very, very end? 2. Because the derivative of the most inner cream is 2. How many terms do y'all see? 1. So let's get all our numbers. What's my number? 4. Nice job. What's the next thing? Come on, guys. Secant squared of tangent of 2x. Okay? What is the next thing that is multiplied? So this secant squared, guys, we accounted for those two right there. Okay? So far, I will highlight to make it easier for you because you're freaking out a little bit of what we've taken care of. Give you the test? Ooh, who said that? All right. All right. So it will be what? Secant squared of 2x. And guys, this secant tangent or secant 2x, I'm not going to be like nitpicky of 2 came before t or no. Just, yeah. And then what's the last piece? The tangent of 2x. Multiplication exists here, here, here. It also exists here, here, and here. And this is completely wrong. Unless I do this. No, I'm not kidding, because on the bonus, you'll see what I'm talking about. It was finding f double prime. Not y prime. It was finding f double prime. They showed all the work, but they didn't put equal to f double prime, so they got none of the bonus.
Well, that's just bullying.
All right. I'll post web assign.